CLion, a cross-platform IDE for C and C++. Download now.
So, shifting left, shifting right. Let me just get my flashcards out. So, we're getting towards the end of the conference for people who are new here or people watching this on YouTube in the future. So, we've had many days of very confident assertions by knowledgeable people at the front of the room, and your brains are probably melted. So, this is my talk, shifting left, shifting right. Arbitrarily, it's supposed to be something about an axis where you put your concepts and how you produce your software, but it's really just a personal retrospective of what we used to do, and having been inspired by quite a few of the talks this week, what we might be doing quite soon. So, about me. I promise this is the very last wall of text you will see in my tech talk, so no more squinting, no more requesting bigger font sizes. This is all going to be fine. This is the world's smallest continuous integration solution, I assert confidently. It's one batch file. You run it, and if you've got Subversion installed on your server, it will start serving builds whenever you commit. That's all you need to do. Subversion, monotonic revisions, you just check in, things happen. It served us quite well. It's good fun. About me. Today, it's going to be me talking about stuff, mansplaining, or maybe it's who-mansplaining. You see that one coming. Shift left, shift right. What do you mean by that? I've got to apologize for my cultural biases here. There's lots of different versions of this, but in fact, we're talking about something like passage of time and that kind of axis. That's, as a scientist, that's what I remember. Of course, I'll be supporting everybody who needs these things in the future. So, I'm only really able to talk about personal experience going back to roughly the 80s. So this is this timeline. This is the before times. I barely remember what's going on there. Tank tops. I wanted to get a picture of the BBC programs because they had beautiful examples of tank tops. 1990s to 2000s, roughly. This was the era of people producing software objects that you would sell for money. Someone's nodding in the audience. The fools. That didn't go very well, did it? Then the web came along, then a better web. And I'm expecting very soon, the last locally installed program will be maybe a couple of years from now, and then we can all retire. So you could all do something like this yourselves with an AI prompt. So I did it for you, and then I won't talk about these things. This is the prompt I used. I'll just briefly go through what I got. January, I ran it through ChatGPT and Claude. That's nice. Already a month later, there were more AI systems. I thought I should include those. So we now have 3 versions. Let's see what they said. These are reasonable presentations, and the presentations are quite good. There are all sorts of stuff in them. Every time it's different. And each time they seem to change their focus a little bit and talk less about what I want and maybe what I want to talk about. But c'est January's was the best one, unfortunately. I asked to have it back, but it said it couldn't. I'm not quite sure what that tells me. Nice diagrams, a few controversial statements. I don't know if there's any JavaScript people who want to say yes or no to that. But this is not what we're going to talk about. I'm going to talk about the things I've worked on, hobbyist and commercial. So really the era of smallish computers, PCs, and moving up to the Linux boxes and the big irons. Build processes. There were and are too many to describe. There's also been talks this week, so I'm not going to go into them too much. But if you must, one that goes back a long time is Make. Make, the inception allegedly is 1976. If you can browse around this month in the Linux source tree, you'll find some Make files of history going back 20 years. Other stuff they've moved. Maybe history's been broken. I don't know how they moved it. That's an important thing we'll talk about in a bit. But it's going a long time. That system clearly works. It has proof by repeated use. That's very special kind of proof. Source control. This is a really interesting one. I mean, some people have retyped their source a few times. We don't want to do that. But what were people using back in the day? A world writable file system did used to work. Tarballs, which would be transferred between individuals. At some point, we started getting acceptance and use of systems that were worthy of being source control. These guys, CVS, each one of those replaced the subsequent one in the list. The commercial systems, this kind of thing would happen. Anyone remember SourceSafe? It was in widespread use. So because this is one of those end of the week presentations, and there's enough people here, enough grey hairs to answer the question, how many people lost all the source at least once with SourceSafe? Is that 100%? My God. Oh, sorry, me too. So why did we put up with this nonsense? It's a really good question. I think, what am I doing? Oh, sorry. Because we didn't know any better, and it was kind of fine, actually. So the homebrew systems, some of those would be effectively wrappers around something else, or they would be literally somebody's conception of what source control is. There's a famous place I worked, place I worked with a famous instance of a hobby project where the guy said he disagreed with other source control systems concepts. They were fundamentally wrong, so his was different. That didn't work out so well. But we made do, which is quite interesting. We didn't often anticipate things like code pages coming along. I mean, I found code lurking in the source tree, not with the poo emoji, but with the ank symbol for some reason at character 180. We never figured out what was going on there. All white compiled, more to the point. Introduction of ANSI, that wasn't much fun. And Unicode, here's an old guy joke. Why are all those icons separated by one character space in monospace? Exactly. Somebody had a special string rendering algorithm and they passed the wrong type to it, didn't they? We got by. Now, source structure is important. If you're just working with a file system, it should be quite straightforward, right? You're just going to put things on the file system. You'll be able to label where they come from, and this is the classic manager diagram. Now, given the title of the talk is shifting left, shifting right, you'll kind of notice that diagram this is the classic one all the managers put up. All the arrows point the wrong way, to my mind, because really the most important thing is the leaf node you've got to start with, which is like maybe B or D. But we're stuck with it. File locking. People used to lock files back in the day while people were working currently on source systems. And there were systems that would impose this. So you would check out all the source, it'd be read-only, and then you'd say, I know that I want to change this file and only this one, so let's go. And it would go off and attempt to get a lock, and off you go. This blocks everybody else from working on it. I know this probably sounds completely mad nowadays, but this is an accepted way of working. At the same time, God bless them, my database people, how do they deploy their software? Well, they could literally just be running it. It's very one-shot. You have to get it right, or you've just lost all of your functionality and maybe some important data. But we made it work. Normally, you need 2 databases for this, really. I think try it on one before you do it on the other. Don't let them get out of source. Sync. And back in the good old days of a fairly wacky environment, we also had things like Rocky Mountain Basic. Does anybody remember the HP 300 series, the HPIB and Rocky Mountain Basic, that kind of stuff? This is Verona Basic. You could load it from disk. And if you wanted to load somebody's slightly better version of graphing a routine, you would load their disk in. You'd say, just load the code, please. It would renumber all of your lines because the go-tos were how the code was held together. And it will work. It was kind of amazing. We used it at my search group. So Elmo produced the best one. By the way, this picture is a real picture. This is I took a picture of this from my garage last weekend, and those fingerprints are probably vacuum grease. Elmo produced the original. Someone would copy it. Duncan was there a bit earlier than me. And then someone would copy it from Tim. Tim was a good sharer. So Tim shared it with Mark, and then I got something from Tim. And then Mark had a better idea, and I stole it from him. And I tried to give that to Elmo. And at this point, the source control system of the hand was employed with no thank you. So we've got that. We've also got people producing portable databases with most of the code in there, most of the system. Power Builder, so the era of the proprietary files, where everything lives in there. How does it work? You don't know. And then Access. Access has the ability to store code pages. I've seen entire applications written in Access. And then the delivery to the customer is you hand them a USB stick. Whether we like that or not, I don't know. So back to source evolution. Languages, all of them somewhat later, maybe than they should have, started to allow you to define really pretty immutable concepts like days of the week as something that goes in the source. So this is on the file, this is in the file system, it can't go wrong, and that will go solidly into A, B, C, and D just from one step. And then you can go even madder, you can have things evaluated at compilation time, but from something that's done from the file. And then recently we've had the idea of embedding an entire text file, literally. So going back to the whole idea of where do these things come from, previously you'd have had a build step maybe that would produce an output, and this was before you build your source. So who remembers the Apache build when you had to generate the char table before you could build the whole thing? So it was platform agnostic, but you had to get the tooling to run first. We've moved on largely from that, I think, and I think for the better, but this is how people think got done. But is it now time to get to the page where we have processes talking to each other? I hadn't realized that the Corba interoperability stuff was so far back, and then DCU actually predates this. DCE, some people who look at the really early stuff for that will look at their COM server definitions and go, these are strangely similar. Well, I personally had a project that could talk from a Linux client to a Windows server using the same libraries on Linux and Windows, if you stick to the base definitions. So this all works. IDL is perhaps an abused file extension, but we have protocol buffers in 2001. So people are still coming up with the idea that you define what's in something, a blob, transfer it straightforwardly, and then boom, you've got your communication. So one of the common models would be something like this. This IDL file sits in the source. Again, from the source, you generate the client stubs. Client and server talk to each other. So there's a messages transferring backwards and forwards. You know it's not going to go wrong. Why? Well, hopefully you checked out all the source at the same time. Hopefully your tooling that generates the IDL generates the right client stubs, and hopefully your client and server are configured to link to those things. It sounds pretty straightforward, doesn't it? Some people go a bit further, of course, because this is not dynamic enough. So maybe you'd like to have a rough agreement that you might be able to figure out the contents of a message based on the client and server. And so you're really just using the underlying stubs as a concept. So, sorry, was that time? Keep going. Source evolution. One thing I have noticed going past a few things recently is I feel personally there's a genuine trend towards much smaller individual commits of source code. I found my all-time history, and I've roughly located it there in 2009, which is like the conversion from roughly ANSI to roughly Unicode for one application. And that was a commit with 4,000 edits touching like all the files of string handling. And then one more check-in recently, which really stands out, is one that was basically a year's worth of grinding away at getting unit tests to work in a Docker environment. Obviously, one of those is Subversion. That was just one hit. And the other one, that's actually the output of the git diff. Still pretty significant. But looking back at my other commits, they're just getting smaller and smaller. I feel some of that is using more and more powerful tooling. This is the lesson of like higher level languages. The other one, I think, it's just become easier because the connections between components are more malleable. Looking back in the past 5 years, I can't see any trend, can you? That's fine. So source evolution. Now, unfortunately, I have been hung on one of my own actual dependencies, and I've not been able to add a slide or two to explain what I meant better. So I'm going to draw it in your minds. Use your imagination. I made a joke that this is the classic manager's diagram about how systems are orchestrated. One of my hobbies used to be drawing the graphis diagrams for applications at the place I work, they are always like this, A and then B to Z with a line from each one, because the libraries supply the functionality and the applications just consume. We never have this elaborate. So it's just a layer of facilities and we put things together. So if we focus too much on making certain things easy, like, oh, I might need to refactor C and D, none of this matters to me as an application developer. I just need the libraries to be there and to work. And then the link and the dependencies will have to manage automatically. This is more and more the trend. But we have library developers punching above their weight in terms of talking about how it's important to manage dependencies. I'm not excited about that. It's never really been of any interest, except when we have an emergency change, such as libraries that are fundamentally broken or vulnerabilities or 0 day and that kind of stuff. At which point, you need to build quickly. That's the only thing that matters. So back to my theme of commits getting smaller, I was thinking about why do we tend to make large commits? Why do we make big, small commits? If I wind back far enough to source control, well, let me ask the question, or audience participation. So how many people recall a project where there was a significantly expensive, like worked on for a decent amount of time, like months or so, a feature branch that somebody embarked upon that was abandoned entirely, or maybe a whole project was abandoned? Okay, some hands have gone up, there's audience. Has this been happening recently, or was this something that we used to be in the past? And I've seen at least 3 instances the refusal of the horse to jump the gate was because the source merge was just becoming too difficult. We didn't have the tooling. We didn't have the understanding of the migration from state A to state B because we'd let everybody else charge ahead like bullets at gates in basically what we would call trunk. And then this feature branch was totally marooned. It just didn't have any of the features that matched, wouldn't pass the tests, sometimes didn't compile because of other dependencies that hadn't been done properly. This is really bad. My observation is that this is extremely rare now. Because we've made those arrows feel smaller in our minds. If I get up tomorrow and think, I just need to split something out, I don't allocate 2 weeks of pain in my life and book the therapy session afterwards because I think it's going to be okay. I've got the support and the tooling, and I'm not going to find myself with marooned code. The alternative, of course, is we might use configuration to abstract our concepts that otherwise would be embodied in the code. So this is actually shifting it right, but that's kind of okay because now you have 2 processes, if you configure them differently, that do different things off the same code. So that's nice. And there are other ways of doing this from the environment. That's nice. It's a pattern. From a database. That's okay. I've seen a few scripts that just source some command line and then invoke something else. So I guess, and this is coming to the end of the talk, and I need to wrap this up and talk about where we are with that evolution. Clearly what's been going on for a long time is that we've had applications that have been difficult to conceptualize what we're changing. And I've got this large magnifying glass to like, this is when we have the tooling, the LLMs that will explain it to us better, we will be able to plan and do our work at a greater level. Whereas our deliverables, which at one point just used to be different versions, the same thing, in some cases non-inspectable, which means, and this has happened, we would write tools to output to text, or we would inspect the database to check whether it was okay. We would find ourselves with tooling to support the way we deliver our software. So we need to imagine that for each one of our systems, the source is a DAG that's moving this way. The application in its environment is DAG above that, moving at a different pace. And underneath that is our tooling, which hopefully doesn't move too fast, otherwise we're playing catch up all the time. And this clearly is begging out for a meme and a pun, so there we go. I've promised to mention Ruby. Another thing that's interesting is some systems are kind of like pluripotent. So one of our needs was to expose a property in a web server, and it's Ruby based. So I didn't know anything about Ruby. I looked into it and said, well, we've got this variable here in this class. And I was like, it'd be really great if it exposed that. Now I was thinking with my kind of like web services and WSDL hat on and ASP.NET. And then I realized that in the Ruby web server, you can just say, look, the variable's there. You can just send it to the client and it just works. And so we did. Didn't have to change anything. You just change the configuration and now it's accessible. It feels a little bit weird that you can just put a magnifying glass in the code and see different things, but it was straightforward. For a dynamic, low-risk system, why not? And that's pretty much what I think. So, in summary, what have we been doing? Well, I hope I've proven the point that we've been doing a lot of weird things in the past, and it was fine. We've also cleaned up a lot of things in the past, and I think there's a lot more to clean up, and I'm strongly suspect that that will become easier in the future. And that's it. Thank you very much.